So let me ask you guys something. How do elementary row operations affect the determinant of a matrix? We're about to find that out, actually. And we're going to be using 2x2 matrices. So let's say we have the following matrix. We have this matrix right here. And if we take the determinant of that, we know that it's going to be 11. Now, let's say we're supposed to find the determinant of B with the same original matrix, but what happens when you interchange the two rows? What ends up happening? So when we interchange the two rows, it's going to be negative 11. Don't believe me? You can do it yourself. Okay, so we know one thing for sure about how elementary row operations influence the determinant of the matrix. And if you interchange two rows within a matrix in the context of determinants, it's going to produce the opposite sign. Now, let's try one more example with the same matrix. Actually, no, we'll use a different matrix. So, let's look at the determinant of the matrix A. From here, we know the determinant is 2. Now, let me ask you guys another question. If I was to factor out 2 from the second row, would that change the determinant? Pause the video, figure it out yourself, let me know what you get. And in the meantime, I'm going to jump straight to the solution. And it turns out that when you factor out a coefficient from your given matrix, it doesn't have an influence on the determinant of the same matrix. Okay. Now let's exercise one last instance with a different matrix. So let's say we have this matrix right here. If we take the determinant of that, we know it's 2. Now, here's where the thinking really begins. What happens if we were to multiply the first row of the given matrix by half? What role does that play in creating, or how does it affect the determinant of the matrix? Go ahead and pause the video and figure it out yourself. In the meantime, I'll jump straight to the solution. It turns out that when you take half of the second row of the given matrix, you get half of the determinant. Does that seem to be the case? Well, notice how in orange, the interchanging first two rows of A changes the sign of the determinant, and adding 2 times the first row of A to second row does not change the determinant. And we're talking about the matrix in teal, by the way. And it turns out in the third instance, when we multiply the first row by half, that actually does influence the determinant. And there you have it. We have uncovered how elementary row operations can have an impact on the determinant of the matrix. And if you like this video, feel free to like, comment, subscribe, and if you have any further questions or help/criticism, please feel free to drop in the comments. Thank you.